Okay, today is day 2 about inverses, and I am starting with this slide right here. It is talking about some properties of inverses. I like to go through these 3 bullet points with you. The range of f is the domain of G. Do you remember that? They flip. So if you've got the domain and range of these guys, I asked before I started the video to have the kids find the domain and range for this red function. Those are going to just reverse to become the domain and range down here of the green inverse function. Okay, so the domain of this red one would be from -2 to, oh wait, domain is left to right, so -2 to -1/2 is my best approximation. Hold on, and a bracket on that. Would you agree with that or not? Why not? But I may not have caught that. I did try to clarify that you're not supposed to use arrows. I'm limiting it to the 2 red dots that I had there. So I was changing the question. All right, then the range of it is how low to how high. It goes from -2 to +2. Okay. So then, to get the domain and range of its inverse, all I have to do is take the domain and it becomes the range, and take the range and it becomes the domain. That way I'll have the domain and range of the green one. All right, that's how to do it with a picture. Now let's talk about finding an inverse, not by flipping it over a line like this, but let's try to find an inverse algebraically. Do you remember the 3-step process where the first thing you do is get f of x turned into y, and then y and x get reversed, and then you solve it for y? Let's see if you can do that on this equation right here. I'll just start with y equals to make it a little easier for you. 3x minus 8. Could you please find me the inverse of that using that 3-step process? I did step 1 already for you. I made it a y equals. I'll pause for a second while you give that a try. Okay, I am actually regretting calling this y in the first place because usually we start with f of x. And the first step is to change it to y equals 3x minus 8. And then you flip the x and y around. X equals 3y minus 8. And then I have to solve for y. So I'm going to add 8 to both sides. X plus 8 equals 3y. And then I have to divide by 3. Divide by 3. And did you get y equals x plus 8 over 3? Okay. Now, would you agree that this is no longer f of x? It's officially called f what? -1, which is also known as the inverse of x. Inverse of f of x. Now, I could give it a whole new name if I wanted to. I could call it Bob. Or I could call it g of x. Or I could call it p of g of x if I wanted to. I can give this any name I want to, but these two are both inverses of each other. I'm going to now change and call this one g of x. I can do that if I want to, because it's a little too weird. Okay, so g of x is this, f of x is that. Now, I just went through the process that's supposed to make them inverses, but yet that's not how you prove 2 things are inverses. If you are going to prove 2 things are inverses, you have to prove this. If you have f of x and g of x, to prove they are inverses, you must prove that when you take f of g of x, you get the same as if you did g of f of x. And they both will actually equal x. When you put the one function in the other function, if they're inverses of each other, it simplifies down to just x. This is a big nasty formula that you will have to know for your test. It's right up there with another one, which was, let's say I wanted to find the domain of that. Do you remember that domain formula? It starts with domain of the inside, g of g intersected with, who can finish that puppy? G of x in df, yes. And ways you can think about that, there's a little bit of symmetry right here that can help you. And by the time you're done with this, you haven't ever used f yet. And it makes some sense that you better use f at some point in this, and so it's in domain of f. All right, we'll talk about doing one of those in a moment, but I'm just showing you there's two big formulas to memorize here. This is where notes are handy. This is why you take notes. This is why, if you're really smart about taking notes, you put like stars by things that are important as I go through and say, okay, this is an important formula now. Because at the end, when you have to study for your test, it'd be smart if you could look through your notes and find anything you put a big star by and study it. This is a skill. Learning to take good notes like that is going to help you as you move into harder math classes and then on into college. Whenever the professor says, okay, now I'm going to do a problem that's kind of important, he's probably saying in code, we're going to test you on this later. Okay, so anyway. So let's show these two are inverses of each other. All right, I'm going to give you the two that we had before. It was 3x. Did I start with 3x minus 8? Okay. And then who can remember what it came out to? X plus 8 over 3. Okay. Now we have to prove that those are actually inverses of each other. If they are, when you put the one in the other, it will simplify down and equal x. So this is the f function that swallowed a g function. So we're going to take the f function and write the f function with an empty stomach, so to speak. That's this function right here with an empty spot where the x is, and then you're going to drop in the g function. Go ahead and do that and simplify it down, and then go to the other side and figure out the g of f of x. Write out that function and simplify it down, and hopefully they both simplify down to just be x. I will warn you, if you don't show your work right, I will mark it wrong. It's about the order that you do things in. You have to use the order of operations. Any multiplies and divides have to be done before any adds and subtracts. So as you're solving this puppy, you can't just randomly cancel off everything. People like to go, oh, that cancels, that cancels, that cancels, that cancels, and cancel them all at once. Math does not do that. Math has to go in order. Okay, so you should have dropped in the g function in here, and that is x plus 8 over 3. Now I ask you, as I'm simplifying this down, you cannot just go cancel the 3's and cancel the 8's and say it's x. What has to be first? Can you multiply it all the way out? Sure, but there's a faster way. Come on, what cancels first? 3's. The 3's can cancel. Why can they cancel and the other ones can't? Because the other ones are add and subtract. Multiplies have to come before add and subtract. So those two have to cancel first. Then I have this. Then you can cancel your plus 8 and your minus 8. And then you do just have x. Okay? On the other side, you have the g function with an empty stomach, and you drop in the f. Empty stomach plus 8 over 3, and I drop in the f function inside there, which is right here. And so I go 3x minus 8. And now this time, a lot of kids learning from the last problem will cancel the 3's first. Wrong. Why do the 8's have to be first this time? The implied parentheses. What is he talking about? Because on a fraction, you have to finish the top of the fraction before you can go on and divide by 3. Okay, so now these guys canceled first. You have 3x over 3, and then the 3's can cancel, and then you have an x. Is it that important, the order? It absolutely is. You cannot. Kids always want to do this. Cancel, 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 and the answer is x. Nope, no credit. Got to show the order. Show that you know that it actually does simplify to x. You can't just assume it'll all cancel. By the way, what if it didn't? What if this one came out to x plus 4? Then they're not inverses. Okay. So that was the last thing I had to teach you in order for you to have learned everything that you need. But there's still a lot we learned. So let's go back in time, do a little rewind here. I briefly mentioned something yesterday that I should reiterate, and that is, if something is a function in the first place, does that guarantee that its inverse will also be a function? No, it does not. All right. I'd like you to prove that by taking this function, which I'm going to call y equals x squared plus 3. Does that make sense? It's parabola shifted up a little bit. Okay. I'd like you to use math to figure out the equation of the inverse for this function. And then when you graph it, you'll be able to prove that that inverse is not a function. Therefore, this original function is not 1-to-1. If it was a 1-to-1 function, then its inverse would also be a function. I can show you a simple one like that. Nope. You get how the red one and the green one kind of look like inverses? Because they're a reflection over the line y equals x. Okay. Then, is the red one a 1-to-1 function? So here's the questions you ask. Is the red one a function? Yeah, pass the vertical line test. Is the green one going to pass the vertical line test? It's close. There's one little zone where it's close. But I intended this to pass the vertical line test the way I drew it. And so therefore, if the red one is a function and the green one is also a function, its inverse, then the red one was a 1-to-1 function because it's special enough that not only is it a function, its inverse is also a function. That's what makes it 1-to-1. Back to this. Have you by now replaced this with x equals y squared plus 3 and then solved it for y? And if you thought it was y equals the square root of x minus 3, you have missed it again. How many times do I need to tell you that the square root of x or y squared is the absolute value of y, which causes you to have two answers, both the plus and the minus of that. And then, if you actually graph that, here is the square root. It goes like this. And then the other one, which is the reverse of that, goes like that. And look at that. Its inverse is that blue parabola. Except it's not a parabola anymore. It's like on its side. And it does not, definitely does not pass the vertical line test. So, was the green one a 1-to-1? No, it wasn't 1-to-1. We proved it. All right, how about this? How about this? F of x is going to be 3x plus 7, where x has to be greater than 5. G of x is going to be 1 over x plus 9. No, actually, those get too complicated for there. This would be better. Square root of x minus 10. I'd like you to figure out the domain of f and the domain of g, and then I'd like you to figure out the domain of f of g of x. This is the one that's going to need that big old brutal formula. Hopefully you've memorized. I'll pause for a second while you give that one a shot. All right. So did you remember it was the domain of the inside one, which is g, intersected with g of x in the domain of f. You got to have that formula memorized. Now, where's the hard part? This right here. G of x in d of f. So here's g of x, and I got to put it in the domain of f. That's the domain of f. And we'll copy it down right here. Domain of f was x is greater than 5, because they told me it was. Way over here, domain of g is x minus 10 is greater than or equal to 0, x greater than or equal to 10. All right, so now I got to put g of x, this guy, into this guy, so I'm going to say x greater than 5, but I replace f with g of x. G of x is square root of x minus 10. And then I have to square both sides. X minus 10 is greater than 25. And then I add 10 to both sides. X is greater than 35. Now, I've got the one, but I haven't overlapped it with the other yet. The other was this, domain of G. What is domain of G? I just look back up here. Domain of G is this guy. X greater than or equal to 10. So here, x greater than or equal to 10. And now I have this overlapped with this, and I like number lines. I really think they help. Here's a 10. Here's a 35. Oh, and not 35. Just to clarify, that is important. There we go. And now, where do they overlap? Right there, from 35 to infinity. So I would say 35 comma infinity can't be 35 because it says right there it cannot be equal to it. There we go. How many of you got that one right? Raise your hand if you did. Okay, good. Yes, sir. I actually did that last hour when I was solving the thing. I made the mistake. We squared both sides. When you square both sides, you don't use an absolute value. When you square root both sides, it's so easy because they have the word square in them. When you square root both sides like this, that's the kind where you have to have an absolute value. Okay? Not when you're squaring both sides. All right, so let's move on. Other things I wanted to review from past days. We can kind of put it all together. You remember those problems on last night's homework? Where I say, here's f of x, here's g of x, and let's say we have a fraction 1 over x plus 2, and let's make this one 2x. I'd like you to find for me inverse of f of g of x. Let's make it a little easier. Let's make it g of 5. Inverse f of g of 5. That involves you knowing how to do domain. It involves you knowing how to do inverses. It involves you being able to do things in the right order. All right, I'll pause while you give that one a shot. Okay, here's what I was hoping you would do. Start with g of 5. You stick a 5 in there. Easy peasy, you got 10. Now it's inverse f of 10. Well, that's fine if you knew what the inverse of f of x was. So now we have to do that inverse process on this. So let's do that 3-step process to find the inverse of f of x. Y equals 1 over x plus 2. And that switches to x equals 1 over y plus 2. Now, what makes this a hard problem at all? Just because it has a fraction in it. So, in the top 20, I taught you how to clear fractions. Hopefully you've got that figured out by now. To clear fractions, you just simply multiply by the denominator. In this case, there's only one denominator. You multiply by y plus 2 everywhere. So I multiply by y plus 2 over here. And I will multiply by y plus 2 over here. And that makes that cancel that. And so now I could distribute this out, or I could leave it alone. Because, why? Because I want to get that x out of there anyway. Do you get what I mean? I'm trying to get the y alone. So why don't I just multiply, or divide both sides by x right now? You could distribute this, or you could just multiply, you could just divide both sides by x. So now, I want to show you there's 2 roads you could take right here, and they're both okay. How many of you distributed the x out? You multiplied it in. Raise your hand if you did that. Nobody? 1, 2 people did. I need you to see what that would do. Okay, if I multiply that in, it'd be xy plus 2x equals 1. Then I'm trying to solve for y. So I subtract 2x from both sides, and I'd have xy equals 1 minus 2x, and then I divide by, what am I trying to solve for, y or x? Something for y, so I'm going to divide by x. There we go. 1 minus 2x over x. Now some of you are going to go, wait a minute, I did it the other way and got something completely different. No, you didn't. You just don't know that your answer is exactly the same as this answer. Okay, let me show you what I mean. Here's the other road you could have gone down. You take this and you don't distribute the x out. You just divide both sides by x right there. And you'd have y plus 2 equals 1 over x. Right? Then I subtract 2 from both sides. And you'd have y equals 1 over x minus 2. I would like for you will need to know how to do this. Find a common denominator for that blue equation. If you find the common denominator and actually add that together, you will get the green equation, and you will need to know how to do that. So what is the denominator on the 2 right now? It's a 1. What would be a good denominator for this? X. You know how to find a common denominator? Good. Do it. You need to know this. Now pause for a second while you give that a try. Did you catch yet that you are supposed to multiply by x on the top and on the bottom, and that'll make you have a common denominator? Then, when you have a common denominator, the answer has that denominator, just an x. And then what will it have on top? 1 minus 2x. Notice it's exactly the same as this. All right. So here's another situation that's similar. Here's f of x, 1 over x plus 5. Here's g of x, 7x. I'd like you to tell me what is f plus g of x, and I'd like you to tell me its domain. And last thing, when you say what f plus g of x is, you have to find a common denominator and actually add them together. If all you do is say, well, it's this plus that, you've left me a math problem, not an answer. You have to actually add them. Find the common denominator. When you're all done, the domain. This is not the kind where you need the great big giant formula. This domain has 2 number lines. I'll pause for a second while you give that one a try. Okay, so here's the problem, but I can't leave it this way because that doesn't have a common denominator, hasn't been added together. So, tell me what to do. Perfect. That will give you a common denominator. Now they both have a denominator of x plus 5. To figure out what to do there, you just take this times this and say, oh, so my answer is x plus 5 would be a good denominator. And you figure out what needs to be multiplied where to make your denominator be x plus 5. The top ends up being 1 plus, and you got to multiply this out, 7x squared plus 35x plus 1. And yes, you can have the 1 at the beginning, but you should rearrange it because it's supposed to be in descending order where the x squared is first and then the x and then the thing doesn't have an x, all over x plus 5. And that, raise your hand if you had that one. Good. That's almost everybody. Good. That is your answer to f plus g of x. Still haven't done the domain yet, but all you have to do on that is find the domain of f and the domain of g and overlap them. All right, domain of f is x cannot equal negative 5. So I'm going to make it in a number line. Here's negative 5. Can't be that. Can be everything else. That's really important. The domain is not the negative 5. The domain is everything except negative 5. Okay, the domain of g is, can I crash that? I can't crash it, so what works? Everything, all reals. You can do this, or you could say negative infinity to positive infinity. And then when I overlap those two things, I'm going to go draw them underneath each other like this. Here's all reals. Where do they overlap? From negative 5 to infinity, and from negative infinity until negative 5 is where they overlap. Whenever you're overlapping with all reals, the answer is just the other one. See? Raise your hand if you had the right domain for it then. Okay, good. Which kind of domain has 3 number lines when you divide? We did f plus g. What if we had done f over g? Then we'd have 3 number lines. And the third number line would be that g cannot be 0. Tell me, in this case, what g of x is, normally isn't it okay for g of x to be 0? Yes. But in this case, when g is in the denominator, you can't let it be 0. So you'd add a third number line that says g can't be 0, and therefore x can't be 0. And here's a 0, and x can't be that. And it can be everything else, from the perspective of only caring about crashing by having a g in the denominator. So then, if you wanted to find where those all 3 overlap, they all 3 overlap in that zone, and between -5 and 0, and between 0 and infinity. So if the divide kind are the toughest, because they have 3 number lines. Okay, we've covered a lot of stuff. It's still not everything by any means, but that was a good day to get a chance to go back and review a lot of stuff and put it all together, so to speak. Your homework last night involved that put it all together stuff. So again, the main thing I tried to teach you today to review the new stuff was there was this nasty formula, f of g of x had to equal what? G of f of x, and if it did, they would both come out to x, and if that was true, then they were really what? Inverses. And one-to-one's different. One-to-one was if you are a function and you have an inverse, this one, by the way, would not be a one-to-one function because its inverse didn't do that terribly well. But here's how you can tell if it would be if the inverse would work. Okay, you agree that this is a function because it passes the vertical line test, right? The thing that tells you whether its inverse would be a function, say it, the horizontal line test. If I pass the horizontal line test, then its inverse is going to be a function, and this does not pass the horizontal line test. Therefore, when you carefully do the inverse on this red function and you get the blue one, it won't pass the vertical line test. Now, I know mine was not perfect by any means there, but it was in that neighborhood, and the blue one you can tell would not have passed the vertical line test itself. So, if a function can pass both the horizontal and the vertical line test, then it's a one-to-one function. All right. So let's actually get to your homework now. I am going to, I know a lot of kids listen to these, not just my students, so I'm going to tell my students which problems of the homework I want them to do. Okay, one of my students noted that on this problem, I never actually finished it. We were supposed to do inverse of f of 10. Miss R, can you shut the door for us? Thank you very much. And gentlemen, can you stay quiet while I'm recording here? Okay, so on this problem, we never actually finished this problem because I never actually stuck the 10 right here. I never stuck that 10 into the inverse of f function. So now I need to go stick that 10 into the final answer. We proved that these answers were the same, which was good and important. But now, all I have to do to finish the question is figure out when I stick 10 in there, what I get. So it just comes down to putting a 10 right here and putting a 10 right here. And I get 1 minus 20, which would be negative 19 over 10. And that answers the question, completes the loop of what was the inverse of f of g of 5. First we figured out g of 5, and then we stuck it into the inverse of f function, and we get this. And that's all we have. Have a great day.